In this video, I'll be trying to provide the solution to the 2024 first semester physics test questions for engineering students. The question here says, 5 coplanar forces lie at the same point P with the following directions and magnitude. So you have the first force F1 equal to 20 degrees 15 Newton, F2 equal to 90 degrees 20 Newton, F3 equal to 0 degrees 25 Newton, F4 equal to 30 degrees 22 Newton, and F5 equal to 45 degrees 28 Newton. The directions of F1 and F2 are taken relative to the positive XY axis, while F3, F4, and F5 are taken relative to the negative XY axis. Present this on the Cartesian coordinate system and determine the magnitude and direction of the resultant displacement vector. Also put the resultant as a single force vector diagram. Okay. All right. So how do we solve this question here? Solution here. Solution. So solution to this question. Solution. My first task would be to write out the given forces. Right. So I'm just going to they use small f here. If you look at this, a small f with the direction there. So, but for me, I'm using capital F. So F1, right? F1 is equal to, the value there was 20 degrees. So I have 20 degrees and I have 15 Newton. All right. Talking about direction of magnitude. F2 is equal to, the value of F2 is 90 degrees. Okay, and then 20 Newton. So you have this. F3, the value for F3 is equal to 0 degrees 25 Newton. Let's take F4. For F4, the value of F4 is equal to 30 degrees 22 Newton. And then finally you have F5. Whose value is given as 45 degrees, 45 degrees and 28 Newton. So 28 Newton. All right. So basically, these are your given forces there from the question. All right. So we have all of these. Now, the next task is to look at the direction. They said F1 and F2 are taken relative to the positive XY axis. All right. So what do you do here? You'd come here and create a Cartesian coordinate system. So I'd come here. Let me try to draw this. So I'll try to draw this. The first one here. That's your horizontal axis. And then you have your vertical axis. So you have this. Okay. You stop here. All right. So you have horizontal and vertical axis. Right, let me see if I can extend this a bit. All right, so you have this. Now let's label this axis here. Obviously, here's your positive x, that's this. Here is your negative x, that's this. Upwards is your positive y, so here is plus y axis. Then downwards is your negative y, that becomes minus y axis. All right. Now, they said F1 and F2. From here, what's the statement? F1 and F2 are taken relative to the positive XY axis. All right. Where's the positive XY axis? From here, it's clear that if I'm looking at positive XY, it means positive X and positive Y, which is this region here. All right. This region here shows you positive X, as you can see here, and then positive Y, as you can see here. So this region here is your positive XY axis. Now, having said that, we'll plot F1 and F2 on this region. So what's the F1 value again? The value is 15 Newton. That's the value of the force. And the angle is 20 degrees. So I'll come here, positive XY. 15 Newton, 20 degrees. I'll come here, put this one this way here. Keep it this way. Okay. So this becomes 20 degrees. You have F1, it's equal to 15 Newton. So we have this. All right. So I've represented F1. Let's represent F2. F2 is the value there is 20 Newton, 90 degrees. So positive XY, 90 degrees would be perfectly vertical. That's this way here. So I'll have F2 this way. So F2 is equal to, the value is 20 Newton. And of course, the angle here, like this, is 90 degrees. So I'm not going to show that, but you should know that if something is like this, what I have here is like 90 degrees. You can see the 90 degrees here, right? But I don't have to do that. So I'll just keep it this way. Right, so this is F2. So I'm done with this. All right. What about F3? They said F3, F4, and F5 are relative to the negative XY axis. Where exactly is the negative XY axis? So you can see that this region here, this is your negative X and negative Y. So we're talking about this region here. So F3, F4, and F5 will be at this region. All right, let's put the value of F3. F3 is equal to 0 degree, okay, 0 degrees, and the value is 25 Newton. Now look at this. If you look at this concept here, we said F2 was 90, right? And you can see that 90 was vertically, like it stood straight up vertically, right? Now, if you're to do 80, what will 80 look like? 80 will be somewhere here. Okay, excuse me. 80 probably will be somewhere here, right? And then 70, and then 60 degrees will now be this one here, right? And then probably now have 40 degrees like this, then 30 degrees like this, then 20 as we have here already, right? And then probably 10 degrees. And then, but the idea is that if it's the smaller it is, the closer it is to the x-axis. That's the concept, right? The smaller the value, the closer it is to the x-axis. In essence, 0 will lie perfectly horizontal. So if I have a 0 degree, it will lie perfectly horizontal. That's the concept of what I'm showing here. All right, a 0 degrees will lie perfectly horizontal. So how does it apply to this question? When we say F3 is 0 degrees and 25 Newton, it means F3 will lie perfectly horizontal. Now they said what there? Negative XY. So it will be this way here on this plane here, but it should lie perfectly horizontal. So how do I represent that? It's just simply you come here, take this one here. That means F3 will come here. So I'll have F3 whose value is equal to, let's see, the value again is what? 25 Newton. So I have 25 Newton. All right, so I have this. So basically, this is your F3 value, right? All right, so F3 done. Let's get F4. F4 is 22 Newton, and the value is 30 degrees. Again, from this region here, 30 degrees means it's moving from the X to the Y, okay? So from here, 30 degrees, somewhere around this work. Let's use this. All right, let's just use this. All right, so we'll have this one here. So this is F4. F4 it's equal to, the value is 22 Newton, and the angle here is what? 30 degrees. This one here, the angle there is 30 degrees. I have this. What's the last in there? The last in there is F5, 28 Newton, 45 degrees. Okay, so 45 degrees, I'll just come here, 45 degrees. Now, to write 45 degrees, all you have to do is this. Come here, choose your particular angle there, this. Right, it's a sketch, so it doesn't have to be perfect. It doesn't really have to be perfect. It's a sketch. Right, so we have this as F5, and the value of F5 it's equal to, we said it's 28 Newton, so 28 Newton, and the total angle for F5 was supposed to be what there? 45 degrees. That means from here to here is supposed to be 45 degrees. But if I do it this way, the diagram looks messy, right? It's messy. So what do? I'll take this off instead. Now, since I already have 30 here, I'll come here and just add what there? 15 degrees. That means total angle from here to here becomes 15, then from here to here plus 30, and that gives you 45. All right, so this is how you draw the diagram. All right, so at least now it looks neater this way. All right, so we're done with this one here. We're done with this. That's the diagram for the coplanar forces. We are asking this question to do what there? Present this Cartesian coordinate system and determine, present this on the Cartesian coordinate system. We've done that. So we've answered the first part, which is the presentation. And this is what it looks like. Let me zoom in a bit. All right. So look at this. This is what it looks like. Okay. I've done the presentation. What's the next task there? Next task now said, and find and determine the magnitude and direction of the resultant displacement vector. Let's find resultants. How do we find resultant displacement vector? What do we do? Now, we'd have to resolve each of these forces to their horizontal and vertical components. That's the concept, okay? Resolve each of the forces to their horizontal and vertical components. Let's start with the first one there. So I'll say resolving each forces. Oh, this is a displacement vector. Let me see this again. Let me see what they said here. Displacement. It's not a displacement vector. It's actually a force. It's a Newton. Anyways, resolving each force to their or to its horizontal each. So each force to its horizontal and vertical component. Its horizontal and vertical components. Let's take them one after the other. Let's start with the first one. Let's start with F1. So first things first, we have F1. That's F1 here. And the value of F1 is equal to 20 degrees. So I have, or they give us this as 20 degrees, and the value was 15 Newton. Alright, let's resolve this to the vertical and horizontal component. This would become, what would it be? What to do is simple. Alright, so in doing this, the first thing you have to notice is that if the angle in consideration is between the force and the horizontal component, that's the x-axis, then Fx, that's horizontal component, is equal to F cos theta. And the vertical component Fy is equal to F sin theta. Again, this only applies if the angle of consideration is between the force and the horizontal line. If I look at F1 here, the angle here is between the force F1 and the horizontal line X. So this formula will work, okay? If you also look at the other forces too, F3, if you look at F2, the angle of consideration we said is 90, which was the 90 degrees is between the force and the horizontal line. You can see that's the x-axis. That gives you the 90. So this same formula will work. If you come to F3, the angle there is between the force, that's F3, and the horizontal line, which we said it laid perfectly horizontal, and we took 0. For F4, the angle here, as you can see, is between the F4 and the horizontal line, which is what there? 30 degrees. And then for F5, is between the angle here and the horizontal line, which is 15 plus 30, and that gives you what there? 45. So we'll be using this formula. Alright, so that's the concept here. Question now is this: what if the angle was between the force and the vertical? So what if we had, let's say, 20 here, 20 degrees between F1 and the vertical, like this, 20 degrees? What do? This changes. So Fx becomes F sin theta and Fy becomes F cos theta. But don't worry about that, since we're not given that. We'll just use our cos theta and sin theta for each of them. So I'm saying resolving to the horizontal component is what there? F cos theta. Resolving to the vertical component is what there? F sin theta. So we have this. Alright, so having done this, that's the first thing you have to note, right? Horizontal component is F cos theta, vertical component is F sin theta. That's the first thing to note. The second thing to note is that when you resolve it, you check for the sign convention. By sign convention, I'll just explain what I mean by sign convention as we proceed. Now let's resolve F1 to the vertical component or to the horizontal component. F1 comes down like this. What do you observe? This is for the positive axis of x, so it becomes positive x, so it becomes positive F1 cos, horizontal is cos, as we said, right? The x is cos of the angle, which is what there? 20. So I'm having positive F1 cos 20. Why is it positive x? Because I'm resolving this to the what there? X axis, and the value of x is what there? Positive. That's the concept, all right? So I'll just go and write this down. It becomes F1 cos 20. Okay, let's see this. Okay, that's equal to, or for time's sake, I'll just go straight to the answer. Okay, so it becomes F1. The value of F1 is what there? 15. That's F1. Then cos of the angle 20. This is in Newton, of course, force, and the would write I. I shows that it is in the x direction or the horizontal axis. That's what it means. Let's get the y direction. So it becomes plus. Let's resolve to the vertical. Now, in resolving to the vertical, it simply means I'll push this force here, this one, push this to the vertical axis, that's here. And if I push this, what do you observe? First things first, it comes to the y-axis. This is a positive y-axis. So it becomes the normal positive, excuse me, becomes the normal positive. The force there is what there? F1. Then we said for y, what do we use there? We use what? Sine, as you can see. So it becomes sine. So F1 sine of the angle. What's the angle in consideration? Please, you see sine of the angle we are using here is still the same angle of 20 degrees. That's the same angle here. That's 20. So I'm having F1 sine 20. So that's what we have there. The value of F1, again, as we had, is what? 20. So it becomes 20 sine 20. The value of F1 is what there? 15. So it becomes 15 sine 20. So I'll just go and write this as 15 sine 20. Let me go and write this. So plus, we now have this as 15 sine 20. This would be in Newton. And since you are resolving to the vertical component, it becomes what there? J. Alright. When you resolve to horizontal component, you put what there? I. When you resolve to horizontal component, you put what there? J. That's the concept. Alright. So this is what we have. Let's complete this. Alright, let's complete this. So this would be equal to just take F1, call this F1. The value is equal to, I'll punch 15 cos 20. So I have 15 cos 20, and that's about 14 points. Now in two decimal places I have 0.95. That becomes 10. Alright, approximately. This is Newton I plus, next up I have 15 sine 20. So I'll change the cos 20 to 15 sine 20. If you punch 15 sine 20, you have in two decimal places, you have 5.13 Newton J. So you have this. So hence, this is the value of F1. Let's call this F1. Let's get for F2. Next up, F2. F2, the value for F2 as given was 90 degrees, and then we're given 20 Newton, right? So let's get this. Let's resolve this. First things first, where's F2? This is F2. This one here, this is F2. Okay, resolve this to the horizontal. It means F2 is coming down. Don't forget, it was taken relative to the positive XY axis. So this one is coming here to positive X. That means with the sign convention, it's positive. The value is F2. I'm resolving to the horizontal. We said we'll use cos. Alright, it's cos of the angle. The angle for F2 as given was what there? 90 degrees. So it becomes F2 cos 90. Now, the value of F2 in the question is given as 20 Newton. So it becomes 20 cos 90. So this becomes 20 cos 90. Of course, we said in Newton, that's the unit for force, and then I, because you're resolving to the what? X-axis or the horizontal axis, plus, let's get for vertical axis. For vertical axis again, observe that this man is actually standing on the positive y-axis, so it becomes positive for sign convention. So positive, positive F2, and since I'm resolving vertically, it becomes what there? Sine of the angle. The angle given there is what? 90 degrees. So it becomes F2 sine 90. Alright, let's write that down. So F2 sine 90. What's the value of F2? F2 is given as 20. So it becomes 20 sine 90 becomes Newton J. Alright, J because I'm resolving to the what? Y-axis or the vertical axis. Okay. So let's get the value of F2. So F2 is equal to, let's punch 20 cos 90. 20 cos 90. The value there is 0. So 0 times Newton I. You don't say 0 Newton I. It's just 0. Okay. 0 times anything is 0. So 0 plus, let's get 20 sine 90. 20 sine 90 gives you 1. That sine 90 gives you 1, please. 20 sine 90 gives you what there? 20. So I have 20 Newton, of course, put the J. This is equal to 0 plus anything is that thing. So it becomes 20 Newton J. So I have this. So here's the value for F2. Let's get the value for F3. F3, next one there, F3. F3, we're giving the F3 as 0. 0 degrees and what? 25 Newton. That's the F3 value. Let's resolve this to the horizontal and vertical components. All right. So for F3, we have this one here. This is F3. Okay. Resolving this to the horizontal components, again, observe that horizontal component is this. This was F3 was taken relative to the negative XY axis. All right. So it becomes negative of this. So it becomes this way here. All right, which is negative. So F3 becomes negative. Why is it negative? Because this is lying on the negative X axis, as you can see here. It becomes negative F3. Then, of course, I'm resolving to the horizontal. We said it's cos, that's cosine. And then the angle was 0 degrees. So it becomes minus F3 cos 0. What's the value of F3? The value of F3 is given as 25 Newton. So it becomes minus, so this becomes minus 25 cos 0, as we said. Of course, this will be in Newton, and of course in I, because I'm resolving to the x-axis or the horizontal axis, plus let's resolve to the vertical axis. Again, F3 was taken relative to the negative x and y axis, so this man will be pushed this way, all right, and not this way. So it will be pushed in the direction of A and not B. Why is it pushed in the direction of A? Because it was taken in the question, they said relative to the negative XY axis. So I'll push this to the word there, negative Y axis. That's the concept. All right. Okay. Let's see. So it becomes negative for the horizontal component. It becomes negative F3. That becomes sine, right? Resolving to the y-axis is always sine. So sine of the angle is what there? 0 degrees. So I'm having minus F3 sine 0. The angle given, if you check, it was 0. So minus F3 sine 0. What's the value of F3? So the F3 is what there? 25. So it becomes minus 25 sine 0. This is in Newton J. All right, let's impute values. We can now say that F3 is equal to minus 20 cos 0. What do you have there? Minus 20 cos 0. That's minus 20. So this gives you minus 20 Newton I plus, let's do minus, so minus 25 cos 0. That gives you minus 25 Newton I plus, let's try minus 25 sine 0. Minus 25 sine 0 gives you 0, and of course the Newton J. So if I work on this, this gives you what there? This gives you minus 25 Newton I, no J component. So we have this. So this is your answer. Okay, so this will give you 0. This whole value gives you 0. 0 times anything there is 0. So that's the concept. So what's next there? F4. Let's look at the next one there. F4. All right, let's try F4. So F4, the value of F4 is 30 degrees. 30 degrees and what? 22 Newton. All right, let's go resolve this. So this will give us what? First things first, F4 is this. Resolve this to the horizontal component like this. That's the negative x-axis. So the sign convention is negative. Then F4, of course, cosine of the angle. The angle for F4 was what? 30 degrees. So minus F4 cos 30. That's what you have. That becomes minus the value of F4 is 22 Newton. So minus 22 cos of the angle there, 30. Of course, Newton of I plus, let's get for the y-axis. Let's resolve vertically. Resolving F4 to the vertical component becomes this way here. And again, observe that it becomes negative of y. So the sign convention is negative. So minus F4. And then what we said when you resolve to the y-axis or the vertical axis, it becomes what there? Sine of the angle. That becomes sine of the angle is what? 30. So minus F4 sine 30. Let's get that done. That becomes minus. So minus the value of F4 is 22. Then we have sine of the angle. The angle there is what? 30 degrees. Of course, Newton, and then you add J. Let's punch this value. If I punch this, we'll have that F4 F4 it's equal to minus 22 cos 30. That gives you the value there's in two decimal places, gives you minus 19.05 Newton I. Okay, next up, let's punch the next one there. So this is plus into bracket minus 22 sine 30. You can punch it that way. If you punch it that way, you have your answer as what there? Negative 11 minus 11 Newton J. Alright, so we've gotten this for the F4. One final one. Let's now do for F5. Right, so I have F5. The F5 value given here is 45 degrees, 45 degrees, and 28 Newton. 28 Newton. Now let's go resolve this. Let's resolve this. What do we have? 45 degrees, 28 Newton. Yeah. All right. So F5 is this one here. Resolve F5 to the horizontal axis that's here. It becomes what? Negative of x. So to the horizontal axis, it's negative. So minus F5. Of course, resolving to x, we said is what there? Cos. Cosine of the angle. What's the angle for F5, please? F5, please. So minus F5 cos. What's the angle for F5? The angle for F5 is actually 45 degrees. So it becomes minus 45 minus F5 cos 45. Let's go write that down. So minus F5. So it becomes minus, what's the value of F5? F5 is 28 minus 28, then cos of the angle. The angle there is what? 45 degrees. And this should be in what there? Newton I. So that's this. Plus, let's get the vertical axis. For the vertical axis, what do we have? Again, let's resolve F5 to the vertical. Of course, this one here comes down this way. So it becomes negative. So it becomes minus F5 into, now resolving, of course, it's negative because, of course, if I resolve this to the vertical, if I push this way, as we said, to give you negative y, so minus 45, and then sine, when resolved to vertical is sine of the angle. The angle there is what? 45. So it becomes minus F5 sine 45 degrees. Now let's get this done. So that becomes minus F5. F5 is 28. They will now have sine of the angle. The angle there is 45 degrees in total, as was given, or as we said earlier. So we have the F5. So F5 it's equal to, you have minus 28 cos 45. That's minus 19 point, approximately this is 798. That will give you what there? 80 Newton I. Okay. If you approximate correctly, you have this in two decimal places. Next, I will punch plus into minus 28 sine 45. What do we have there? That becomes minus. So if you punch all of that, you have minus the same thing. Minus 19.80 Newton. Now this one becomes what there? J. Now by the way, I didn't add that there, so I'll just add this here. I'll just add this here as Newton J. Alright. Alright guys, so we've gotten the value of F1, F2, F3, F1, F5 resolved to their horizontal and vertical components. At this point, we can now get resultants. So our next task here would be to find the value of the sum of all the horizontal forces and the sum of all the vertical forces. Alright. So let's take the sum of horizontal forces. So summation of horizontal forces, right? This is actually sigma fx, right? Let me make a capital F, sigma fx, summation of horizontal forces, and this is equal to, so to get this value, we'll simply look for all the values with I and we'll add them together. All right, so you have the first one there, 14.10 Newton I. So I have this as 14.10 19.10. Or we could just write this. We'll use the Newton I at the end. Plus, let's get the second one. For F2, there's no I value. I'll leave this. I'll come to F3. For F3, I have minus 25. So it becomes minus 25. Let's get for F4. For F4, for the I, we have minus 19.05. So it becomes minus 19.05. And then for F5, you have minus 19.80. So minus 19.80. So let's sum this. What do we have? We'd have that sigma fx, excuse me. We'll have this that sigma fx, it's equal to, now let's impute values here. So first things first, the first term we have there is 14.10. So it becomes 14.10 minus 25 minus 19.05, then minus 19.80. Right, so if you punch this correctly, your value should be equal to minus 49.75. You have this as your answer. Minus 49.75. All right. Of course, you now add the Newton I. Of course, you should have added here all of this into Newton I. Right. So all of them had Newton I as an SI unit. So we have this. Now this is for horizontal forces for the X. Let's get for vertical forces. All right. So we'll take summation of vertical forces. Let's write this here. All right. So let's take summation of vertical forces. So summation of vertical forces, and that becomes sigma force F, vertical is Y. We'll have this. So all we have to do is just go back and pick up all the values for J. All right. The first we have there's 5.13 Newton J. I'll just take 5.13 plus, put this in the brackets. The second J value is 20 Newton J. So it's 20 plus 20 plus, what's the next value there? After this next one, there's what? There's no J here, it's just I. So I'll leave it up. Okay. Come here, you have this one here, which is what? Minus 11 Newton J. So I'll take this as minus 11. Minus 11. What's next in there? After minus 11, next we have there is the next J we have there is minus 19.80 J. Alright, 80 Newton J. So minus 19.80 minus 19.80 all in Newton J. So we have this. Let's impute values. So sigma, let me write this properly. So sigma Fy, this will simply be equal to, let me punch all of this with the calculator. 5.13 plus 20 minus 11 minus 19.80. I'm having this as a negative. If you punch it, you have this as minus 5.67 Newton J. So you have this. All right, so now you have the value of sigma Fy and of course sigma Fx. Now to get the resultant, we have to find the magnitude and direction of the resultant. For resultant force, we'll have that resultant force, let's call this Fr. This, now the formula for this is simply equal to the square root of sigma Fx all squared plus sigma Fy all squared. So note that this is the formula to calculate the resultant force, and this is simply equal to the square root of sigma Fx. What's the value of sigma Fx? Let's see. The value there is this minus 49.75. So we'll take minus 49.75. All right, that's the first in there. Minus 49.75. That's sigma Fx all squared plus, let's get sigma Fy. Sigma Fy, let's look at this. Okay, so we have this here. The value, as you can see here, is minus 5.67, minus 5.67, this one here, all squared. So we have this one here. All right, let's work on this. This is equal to the square root of, let's take this. All right, so don't forget that if you're typing the minus 49, you should put it in brackets. So open a bracket, type in minus 49.75, close the bracket, and then square it. All right. If you do that, you have a positive answer of 24 or 2475.06 approximately, right, in 2dp plus, let's get for the next one there, open a bracket, type in minus 5.67, then square that, you have your answer as 32.15 in 2dp. Let's sum this. This is equal to the square root of 22475.06 plus 32.15. My answer here is 2507.21. So the resultant force, that's sigma, or the resultant force Fr, will be equal to, let's get square root of this answer here, square root of 2507.21. The answer there is 50 point in two decimal places 0.7. Now note that this value would be in Newton because it's force, and it will not come with I or J. It's just 50.07 Newton. This is the value of the resultant force, that's Fr, right? All right. Now again, if you're also asked to let's go back to the question. Then let me show you something. Look at the question there. You are asked to find, let's see, you're asked to and determine the magnitude and direction of the resultant displacement vector. Let's get the direction of the resultant. It's not a displacement, it's a force, but let's take direction. So for direction, here's a formula. Note that tan theta, so tan of theta, is equal to sigma Fy all over sigma Fx. All right, that's what you have there. So from here, we'll have that tan of theta. So tan theta, is equal to, what's the value of sigma Fy? Sigma Fy, the value is simply equal to minus 5.67. So I have this as minus 5.67. This all over, that's the value of sigma Fy. Let's get the value of sigma Fx. The value there is 49.75. Let me just confirm that. 49.75. All right, so that's it. So is that negative? Yep. Minus 49.75. So that's minus 49.75. Right. So if you do this, we'll have that tan theta. So tan of theta, it's equal to, I'll just get my calculator and punch this. So minus 5.67 divided by minus 49.75. Right. The answer there is 0.111139. So just take 397 approximately. That's the value. To get the direction, theta is equal to tan inverse, of course. I'll take tan inverse of the answer there, 0.11397, right? And from this, we'll have that theta is equal to tan inverse of 0.11397, and that's about 6.5, right? 50 actually in degrees. All right, so I've gotten the magnitude of the resultant force, which is 50.07, and the direction, which is 6.5 degrees. That's it. What's next in there? And last task there said we should also put the resultant as a single force vector diagram. How do you put resultant as single force vector diagram? What do you do? Now, the first thing you have to do is that let's rewrite the value of the resultant. Resultant force Fx or Fr is equal to, let's see the value of Fx. All right, let's take sigma fx. I want to show you some from there. Observe that sigma fx is equal to minus 49.75. So that's simply equal to minus 49.75 Newton I. Okay. For the J, let's see for the that sigma y or sigma fy. The value is minus 5.67. So that would be minus 5.67 Newton J. Alright. Now when it comes to drawing the diagram, all you have to do is to get the value of sigma fx, which is this, and sigma fy, which is this. Now observe that the value of the sign attached to the fx is negative. That means fr will fall in the negative part of x. Now if you have a Cartesian coordinate like this is positive x, this is negative x, upwards is positive y, downwards is negative y. Observe that the sign attached to the sigma fx is negative. That means it will be in the negative x region. That's one. Also, observe that the sign attached to the sigma fy is still negative. That means the resultant force will fall in the negative x. You can see a negative x, and then here to negative y. All right. So the sign convention will tell you where it will fall. So hence to fall around this region here. All right. This is where sigma fr would fall in. Right. Negative x, negative y. That's the concept. So if I had positive x and negative y, it would have been positive x, which is this side here, this way here, and negative y. It would have been this region, because this is positive x and this is negative y. But we have negative x and negative y. So let's now draw our main diagram. Our main diagram will now look like this. So here, also have here too, right? You bring this down. Don't forget we said this is the part here, which is negative x and negative y, as I showed you earlier. Is this quadrant, okay? Right. So negative x if you want to, and then of course here negative y. Then the angle you calculated will now be here. That's the angle between the resultant, that's fr. I'll put this here, fr, whose value is equal to the value of fr again is what? Let's see. Fr is 50.07. Okay, so fr is equal to, we'll have this as 50.07. Write this here. Fr is equal to 50.07 Newton. Then the angle here would be theta, being equal to what you got earlier. Let's check that value for theta again. Going back to check the value for theta, let's see. The value of theta is what? 6.5 degrees. Right. So going back to this becomes 6.5 degrees. All right. So you have 6.5 degrees. All right. So it will be between the resultant and the horizontal. That's the concept. All right. And that's it. So that's how we get this. So basically, this is how we answer this particular question. All right. So that's the solution. That's the diagram. Any other thing again we have to do? Let's see. As a single force diagram. So basically we've done that, and that's how we solve this question. Okay, so this is your single force diagram. All right, this is how it's done. So if you enjoyed this video, please do well to hit the like button. All right, so please like this video, leave a comment, tell us a thank you. If you have any question, leave it in the comment section. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do well to hit the subscribe button, click on the bell icon and select all, so that you get notified whenever we upload new content. Then finally, share this video to your friends, your classmates, your colleagues, so that they can also learn. Don't forget to check out my website, www.jonaemmanuel.com/courses, to check out any of the available courses, or www.jonaemmanuel.com/books to see any of the available books, past questions, scholarship past questions, and etc. Okay, register an account to the website and then proceed to get any of the available courses or books. Right? Alright guys, so as usual, thanks and see you in our next class.